Right, mug of brain fuel refreshed. I found my cutters on a piece of paper outside of me. I'll put those old ones on. So now basically the same thing at that the other side of the 7 segments. Get these stray bits out so they don't build up. Get in. And I'll start at the that end. I think it keeps it maybe a little bit easy to keep track of it, which pin I'm on, rather than working down from the top. Yeah, that's the bottom pin on that side of the top display. So that goes to the bottom pin on that one there. Again, because it's an otherwise blank row of just continuous pins, being a bit extra careful I don't lose track of what's what and make a total mess of it. Which again doesn't do any physical harm. Oh, that was a bit long. Doesn't do any physical harm, but it's just a waste of time. Better off checking first. That's that one. Got 2 uncut tracks next to each other there, which is not right. That one should be cut. Try and get rid of the bits of swarf. Yeah, that looks like it's cut cleanly. Right. The bottom pin, which is that one. Actually, like there's a bit of something just stuck in that groove in this thing. Just occasionally it goes so far and the wire starts to jam slightly. Just about there. It's before the insulation gets in, so it's not that. Anyway, whatever it is, it should wear away or fall out or something. So I've got that first one a little bit long, but it doesn't hurt. Just hide it. Let's get a bit more off the reel because it's the end's starting to pull back and vanish. I've got power tools for this, but for whatever reason I just prefer the hand tool. I think it gives you more control. You can feel the angle of the pins better. If you're working on a mass production thing where you've got a massive board in a fixed rig, then a hand tool where it's a fixed angle again against that, it's probably easier. But when you're holding everything by hand, it's a lot easier to feel the correct angle with a light tool like this, so you're not bending pins. You can feel the load as the wire starts to wrap as well. You can get an idea if it's going correctly. Because if there's too much insulation built up underneath and it tries to wrap over it, it can be too big for the tool. You can feel it suddenly get quite stiff. You know, you've got to just lift up a little bit, take the pressure off it, so it'll stack the insulation turns rather than breaking the wire. So we just got more tactile feedback with it. I think that's the end of the second chain down that side. 2 to go, 2 chains. And that's all the segment bus in. probably one of the most repetitive bits. The next one's up the cathode, so I'll skip that and go to that. Like I say, I've already mentioned, but doing an IC board like the others I've shown you, then there's a lot more time involved in making sure you've got all the power and ground connections wired in first, where possible, with direct copper connections. And also adding decoupling capacitors under all the ICs and the other discrete components that are more convenient under the ICs or close against them, whatever. Because you don't really want to be soldering to pins once they've got wrap on them, because it's going to solder the wrap as well, make it difficult to work on in future. So any soldered discrete stuff wants to go first. Whatever reason, that side looks to be coming wider than the other side. I think it's because that side I was stretching and barely be able to reach the stuff, and this stuff I've got plenty of room to work on it. So it's my hands in a different place. I also always, bend the wire once it's in place. Then you can tell if it's starting to lift. Where if it's straight, it's very difficult to see if it's starting to lift out the tool. Seven sets of segment commands. there's actually 8, so one to do. I think it's actually, according to that diagram, this is actually pin 1 and 1 now. Very last one to do. This segment E, apparently. Okay, so looks like that's that one there. Just that on the end of that first one, there's the pins at the starts of the chain, and then that next one down has still also only got one wire on at the moment, but that's where I need to be carrying on from. The rest are a little bit more obvious because there are no single ones till at the end. Segment E, by gone. Right, done. Okay, so that's one bit of it, which is that common bus on the bottom of the displays there as it's drawn. They're driven through the resistors that are yet to be fitted, 100 ohms, from the MIC 5891. So if I want to finish the segment section, I need to fit the resistors next. Use the soldering iron back on. some 100 ohms here gone out. Okay. For some reason I've got 6 instead of 8. I must be getting mixed up with the cathode drivers rather than the segment drivers. Just really get rid of some of these cuttings as well before they get spread too far. Right, take resistors. The sticky ends. So 4 of these are going against the pins on the driver IC. There's just enough room to fit them in. I've got three holes there, only 2 at that side. The stripboard. Been a bit sneaky and soldering them directly to the pin at one side. I can just fit in some resistors. The others are going to get laid across here in that space. So they're going to get folded directly, and then it's the bottom 4 pins. So that's the pin 1, so we'll call that the top. The bottom 4 pins of the IC at either side are the outputs. So that's there, so they're going to go on that line there. So one side's actually going to solder in. Again, this is a typical space saving sheet. One side will solder to a bit of a pad on the stripboard they've left in place. The other will get bent over fractionally and solder against the base of the pin. I definitely want to solder the ones on the pad first for 2 reasons. One, it's easier to solder. The other is that's the far end of the resistor, so I'm not going to burn my finger holding them in place. The one that connects the IC pin is the one that's bent around the top the way I'm fitting them. So that's going to get very hot very quickly. So if I can hold those in line for a bit. And I'm going to be, to do these, I'm using the end of the solder. I've got to try and kind of arrange it. It's sometimes easy to do it over the edge of the bench. But basically put a kind of hook on the solder so you can work it in, hold the part with one hand, soldering on with the other, and manoeuvre them both to the solder. I just want to flow. Ouch, that's starting to get one. It has gone, but not very well. Okay, plan B. How is that bit of I was using kitchen towel stuff. Put that over them to hold them in place, so I can work from this side. And I'm not having to try and wedge everything quite the same way. Just about get the solder through between the IC pins. Oh, by the way, I've got a soldering iron sponge damped with deionized water just out of the view of the camera. So a tip on a forum a couple of years ago, using deionized water, it means the sponge doesn't go hard with limescale as the water keeps evaporating out of it. So they'll last a lot longer. I'm not really happy with these joints, but I can tidy those up once the other side's in and the wires are trimmed. At the moment it's just something to hold the resistors in place. I think it's more important than them all looking pretty. Just realign those so they're all looking neat. And it's going to be quite awkward. I suppose really I should have done this before I put that socket in place. We're not going to take it out now. So I'm going to a bit of an odd angle. Also cut the other pins, just leaving them a few mil long. We're going to get left a few mil long because I can't get in properly to cut them any neater. No, can't get into that angle. I'm going to go from the top or the bottom end. Right, they're all cut, but they're probably sticking out 3 or 4 mil above the board at the minute. So I need a screwdriver and I'll just try and arrange those against the pin. There's not going to be a wire on these pins. They only connect to the resistors, so I don't have to worry too much about the joints being a bit high. The important thing is they've got a good electrical connection. But once they're bent in a bit, I might be able to trim them better, and it's a better angle to get onto the wire. They're a bit long still. Oh, that's better. Trim them to a couple of mil so they will fold more or less against the base of the pin. Again, this is not particularly different to working on anything built with conventional sockets or direct hardwired, except the pins are in the way when you're trying to actually do stuff like that. So it does ideally take a bit of better planning. Can also cut those down a bit more now, I think. Now the other wires are out of the way, got me a better access. Sorry, just nudge the camera again in my head. Okay, so how much you can see of that. The ones down the centre of the row are just tack soldered in place. The other side, the wires are cut fairly short and bent part way over the solder joints, so I can flow them into the joints properly now. Well, it's not exactly the right place for that, but I can't move it without messing up the camera view. Okay, they're all in at that side. I can go over the joints at the other side again and try and get them tied up a bit. Better. They're properly flowed now. Still a bit lumpy, but they're fully flowed. I can then put wires on them. Right, then the other 4. I've got to go out in a few minutes, so I'll just try and get this bit done first, and then that'll be it for this section. I think if I bend those sharply, they will fit in that bit I've cut there. And that I've missed. I've gone straight through both cut holes, so one row higher. That's better. after they're both in pads or bits of track. That's the other 4 resistors in. Just bend all the leads out a little bit to stabilise them so they don't drop back through. And they can be soldered in. Side of that, it's not flow pro, that's it. And this strip board is supposed to be coated with a kind of flux layer, which is why it's not tarnished. But sometimes it takes a bit of assistance and a bit of extra heat and time for the stuff to actually allow solder to flow through it or under it. So other times it will flow straight along the track without any problem with exactly the same heat and same amount of solder. Like I say, I think it's just either old or not very good quality or both. I'll trim those back. And they're very sticky ends from the bandolier they were on. That's one that was being awkward. That second one down, you see it's not followed along the track very much, so just give that a bit of extra assistance to that side. There we go. Right, okay, so that's all the resistors in. So those are already connected to the IC at one side. These need linking to the IC. So for that, what I normally do is just do a very short strip of cutters, and you can just tin that end and put it into the component solder. And keep those in the same order as the pins. So that's the 4th one in. That messed up. I touched the other joint because I'm working over the top of it, and it's both released that wire and bridged it, so I have to sort that out. I should be working towards myself really well in a way that I'm not going over the same joints I've already done. But I can hold that back down. Flow it back in. That's that. Just a bit more careful. Oh, there's a blob of solder on the eye. I know if it was just at a funny angle with it. Got too low. Oh, just done that. Need a short to solder. Almost. Get the habit of doing that. Okay, so that's all 8 resistors connected to the IC at one end. Now they need connecting through the segments. I've got to figure out from the drawing which pin is which. So starts at pin 5 and then works round in sequence. A to F, then the decimal point. So pin 5 is the first of those fixed resistors. So I have to go through the IC pins outwards to avoid overlapping the joints. And that's going to go, it goes in the IC, around the end and back down the LED section. And then pin A on those is pin 7, which in turn is 5, 7. It's the one above centre there, looking from this side. You saw it then, the way if you leave a loose wire like that, as you start wrapping, then you grip in the tools enough so it will actually wrap a bit of excess wire in and neaten up the long wire. So segment B is pin 6 there, and at the other end it is pin 6, which is the top right. So this is somewhere you need a screwdriver somewhere. If we're working with wires between other pins, it's useful just to push them down gently. So that's that one. Because if they tighten up whilst they're above the existing wraps, they can get in the way. And also the whole lot just gets thicker for no good reason, because they start piling up in mid-air rather than just laying neatly. Now, I'll see if I can show you that, if it works, this one. As I wind that in, it initially puts a little bit of tension on that link wire until there's enough to hold it, and the wire starts wrapping rather than just pulling through. I put that in the wrong place, haven't I? That was that was supposed to come down there. Take it off again. It doesn't affect it electrically, but just neatness wise, and it's a good excuse to show unwrapping using the other end of the tool. Just gently push. Until you can see it's unwrapped. The spiral just expands. It stays as a spiral, but it expands. Now, strictly speaking, you should replace the whole wire, because it may be a bit fragile after being wrapped up like that. Oops. But as long as you unwrap it carefully rather than just pull it and allow for kinks, so you put a piece of wire, a component lead through the hole, through the centre of the coil, and just pull, it'll unwrap. You can actually see there, hopefully, all the individual kinks in it, which are all the point contacts around the pin where it had the spot welds, effectively, or high pressure points. Just if it'll stand being, pull through your fingers a few times to straighten it out a bit and go back in the tool, then it should be okay. So put that back where it should be, there, same as the other one. Back on that pin, see if it wraps okay. It'll either wrap or it'll break. If it wraps, it's good. Yep, that's gone. Okay. Now, if it got any kind of kink or crease in it too hard, it would have broken either when it's been straightened out or when it was being wrapped back in. But as it's not broken, it's fine. And look, I wouldn't do it if you're building kind of military specification gear, but for hobbyist stuff, I've never had a problem with it. It's getting a bit messy. Right. That's segment C, which is pin 4 according to the drawing, which is next to the last on the bottom row, or next to the top working upwards from this side, so it's there. That's fourth pin across, pin 4C, yes. Now that would be pulling round a rather sharp angle to take the slack out. So I'll just push the slack into the space, and then it takes very little force just to pull that last bit in and keep it neatly in. The fourth one is segment D. Segment D is pin 2. So it's the second one from this end on the bottom row, which is right there. Now that might be a little bit awkward because it's going to be pulling backwards around the first pin to forward around the second. So again, I probably want to give it a bit of a hand just to get that loop of slack out of it. Make sure that's pushed right up there, so the loose bit's already inside there. Then when I start wrapping, it's just pulling in without dragging around things to keep it neat. Okay. Right, then we're on to these resistors here. Now with these, rather than going a long way around, I might as well take these straight inwards and just to whichever pin is convenient. Well, I'll take them all to that end one just for consistency, I suppose. So now to the IC, the start of the next side, which is pin, is the resistor that connects to pin 9. That's the 5th segment, so it's segment E, which is pin 1 on the displays. Pin 1 is the bottom left we're looking from the front, so it's that bottom end one. And again, that's going through between already wrapped pins, so just make sure it's seated well down in the gap. I don't want it too tight, so I'll just hold it back a bit because it's trying to tighten in really hard on there. So this one's the resistor on pin 10, which is going to be segment F, which is pin 9 on the display, which is next to the top left corner. So it's that one. I'll just steady it so it doesn't pull too tight. Right, 2 to go. So this is the last segment as such, as in letter segment, which is segment G, pin 10. Yeah, so you see what I mean with that. There's loose coils around those pins already. If you just pull it, it can end up on top of those coils. So try and push it low down so it seats in neatly. So pin 10, segment G, pin 10, that's the very top left from the front, so right looking at the bottom. So that's that one. I'm putting them all on this same one right at the end. There's 2 reasons. One is it's only got 1 wire on each terminal so far because that's the end of the chain through all the displays. And the other is it's easy to see, well, there's 3 reasons actually. That makes it easier to see if I missed anything because there should be 2 wires on every pin that's got anything connected to it. So there's only one at the moment in that that's not got a connection, which is pin 5, and pin 5 is the decimal point. So that is correct. I've not swapped anything up between the segments, or at least not at that point. Oh, and the other thing is it's easier if you change it to keep it to 2 wraps of said pin if you can. Although these will take 3 or even 4. If you do ever have to change anything, having more than 2 means it's quite tedious to undo everything and replace it afterwards. Because Murphy's law says it's always going to be one of the bottom ones that's hardest to get to if you need to change anything. So that's the last segment resistor. Again, push it well down, and that's going to pin 5 there. Okay, so now the center pin, that 5 pin is one end display, and all the used pins, I've got 2 levels of wrap on, so that looks consistent all the way through. And the centre pins are the cathodes that I'm not going to use just yet. They're in the next section, possibly. And that's all the individual segment wiring back to the driver IC. Done. It's starting to take shape. Oh, just trivia, as I was saying earlier, that these wire up pins, about 0.7 mil square, because sockets are quite expensive now, and you can sometimes only buy them in full tubes. If you're needing small quantities of a type, it's easy to get these pin strips, which you can get in either 20 or 32 or 36 long sections, because you can just break those as needed and use those to make up your own sockets of any size, rather than having to buy a tube full of 40 pins or 28 pins when you only want one. There's 2 of these strips make a 40 pin IC. But yeah, what I was saying, these, if I get on one pin, now it's saying 0.62, I thought it was 0.7, but might be getting mixed up with a diagonal or something. No, that's about 0.9 diagonal. Anyway, whatever. They made me skin these down a bit as well for cost over the years. 0.63, that's a proper wire up pin, a turn pin, a high quality one. A stackable header, would you believe? We don't over squeeze it. 0.63. They're based on the same standard. Any true branded quality header pins are also wire up pins. So you could use these as wire up connectors.